Hello students, today we are going to see something important, that is alcohol, phenols, ether. In this session, we are going to learn some conceptual based question. What are they? Why do we say it's an alcohol? What are the types of alcohol? How can we classify? How to interrelate it with other topics? See, these are all the points we are going to see today. And here, alcohol, generally OH group, it's an alcoholic group, right? OH group attaches with aliphatic and aromatic. Aliphatic means generally alkyl groups. Aromatic means benzene in that OH group directly attaches, that is phenol. And the same way ether, what is it ether? In that OH group, hydrogen is replaced by one alkyl or aryl group attaches, that is ether. Yes, let us go for it. CH3, CH3, CH2, OH. This is alkyl group attaches with OH. It's an alcohol. C6H5OH. This OH group attaches with benzene, removal of one hydrogen. So that is phenol. And this is aromatic alcohol also we can say. And another one, the same way, CH3, CH2, OH. In that OH, hydrogen is replaced by one alkyl or aryl, CH3 or C6H5. So this is ether. So here generally we say RO R dash. Here what it is? Phenol. The same C6H6. One hydrogen is removed by OH. The same way CnH2n plus 2. One hydrogen replaced by one OH. So these are the points we are going to learn. First and foremost, we are going to see aliphatic, then aromatic. This is phenol, this is alcohol, and this is ether. Okay. Now let us go for the complete session of alcohol, phenol, and ether. Okay. Now in this point, alcohol classification. It's very important, easy to understand. Yes, let us go for that based on the number of OH group. First point, it is based on the number of OH group and it is based on the hybridization. What are the hybridization? sp2 and sp3. That is based on that. So these are the 2 points we are going to see today. Okay, based on OH group attaches with that alkyl group. How many OH group attaches to the alkyl? So according to that, monohydric, generally hydric, hydroxyl. We can say it is a hydroxyl group only. Hydroxyl, hydroxyl. Hydrogen and oxygen is there, so we can say it's a hydroxyl only. Okay, now monohydric alcohol. So how to say monohydric alcohol? So only one OH group which is attaches with it. So CH3, CH2, OH. General formula. Okay, easy to identify. Methyl alcohol, ethyl alcohol, propyl alcohol, butyl alcohol. So many. Only one OH group it is there. That is what mono. Now dihydric alcohol. Dihydric. Dihydric means two hydroxyl group. Dihydric alcohol. Alcohol means two hydroxyl groups. CH2OH. The same way CH2OH. Now, this is for example, imagine this is CH3CH3. Ethane. In that ethane, one hydrogen is replaced by one OH, another hydrogen is replaced by one OH. So what do we call this is ethylene glycol. Ethylene glycol is nothing. That is dihydric alcohol. So one OH group, it is replaced by one hydrogen. Now trihydric. Trihydric. So trihydric, it is what it is. CH3, CH2, CH3. So CH3 means each one hydrogen. Now here one hydrogen it is removed by one OH. Now here also one hydrogen is removed by one OH. Here also two hydrogen is there in that one hydrogen is removed by one whole. So what is the name of this formula? CH2OH, CHOH, CH2O. So this is called glycerol. Glycerol. So glycerol is nothing. In big cereals and all, they'll add the glycerol, for crying purpose. So that is the compound name. This is the formula for the compound glycerol. Now polyhydric alcohol. How to go for polyhydric alcohol? Polyhydric hydric alcohol. So polyhydric alcohol, simple it is. For example, CH3, CH2, 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 1, 2, 3, 4, 5 and CH3. Now this is hexane. In that hexane, everywhere one hydrogen is replaced by one OH. So here OH, here OH, here OH, and here one OH, it is replaced by one hydrogen, and here one OH it is. So if 1, 2, 3, 4, 5, 6, 6 means hexanol. Hexanol, OL, right? Alphabetical, IUPAC name, OL. So hexanol, okay? Now another one more name, it is called sorbitol. What do we call? Sorbitol. Sorbitol, OL. So these are the names. In choose a correct answer or give one example of polyhydric alcohol or trihydric alcohol. Such kind of question you may get it. For that I'm bringing here. Okay, now next one, what we are going to see based on the hybridization. Based on the hybridization, this is based on the OH groups. How many OH group it's going to attach with that alkyl. Now here we are going to see based on that what it is. Hybridization. Hybridization here sp3 and sp2. These are the two hybridization only will be coming. Now let us go for that point of that classification. Hope you understand monohydric, dihydric, trihydric and polyhydric. Such kind of question comes means I hope you are able to identify. Now, a compound containing OH group attaches to the saturated carbon, that is called sp3 hybridized. In the three groups are there. The first group, primary, secondary and tertiary alcohol. The second one, allylic alcohol. Allylic alcohol. Then third one, benzylic alcohol. Aromatic, benzylic. So all these things, all three groups, that OH group attaches with that saturated hydrocarbon. So that is called what it is? sp3 hybridized, 100%. Now, for example, primary. How to identify CH3, CH2, OH, ethyl alcohol, methyl alcohol, butyl alcohol, propyl alcohol. So number of things, only one OH. Now secondary alcohol, what is it secondary alcohol? Now in that secondary carbon OH group attaches CH3, CH, OH, CH3. Now CH3, CH2, CH, OH, CH3. Can you name this? This is three carbons of propane, propane, two all, OL all. Second carbon OH. Okay. Now this in that 1, 2, 3, 4. 1, 2, 3, 4. So this is butane. Butane two all. 1, 2, 3, 4. So whichever it is, lesser number of carbon. So butane, butane, two all. So this is the way you can name that. Okay, now next one, tertiary. How can you mention tertiary? It's very simple. One carbon is attached with bulkier group. You have mentioned a number of times in SN1 mechanism. So CH3 here, OH here I put CH3. So all bulkier group, one OH which is attached over here. So this is called 2-methyl 2 propane all. So what do we say? This is 2 methyl, okay, 2 propane all, propane all, okay, 2 methyl, 2 propane all. So in that way also we can, so primary, secondary, tertiary, it's very easy. Now the second one, allylic, and third one, benzylic. So what it is allylic? So the OH group which is attached to that, what it is, saturated carbon that is adjacent to that double bond. Yes, let us go for it. CH2 double bond CH, CH2 OH. So in this, here, I brought many examples here for you to understand that OH group is attached to the saturated hydrocarbon that is connected with the double bond. That is called allylic alcohol. So, here, this is actually sp3 hybridized. The double bond which is attaches to that, what it is, saturated hydrocarbon that is attached with OH. So allylic alcohol double bond will be there. Allylic, benzylic, benzylic it is aromatic. Allylic which is a double bond, alkene. Alkene alcohol also we can say. Okay, now how to identify the naming? It's very simple. First and foremost, we have to give the priority for functional group. So how to name that second point? You have to give the priority for double bond. Now here 1, 2, 3. So here in this way, first carbon connected with OH. But here how many carbons are there? 3 carbons. So according to the parent wise, so here propane, prop, 2 1 all. Right? Prop 2 second carbon only double bond. So 2 1 all. And third one here, this point 1, 2, 3, 4, 5. So pentane, pent according to the parent name. So here pent here actually 2 all. Actually third carbon which is attached with it, pent 3 2 all. Got it? So according to that parent name first, and in that carbon which is attached that ene, and then first priority for the functional group. Okay, now here this is cyclohexane, cyclohexene. Okay, cyclohexene means cyclohex, 1 ene, 1 methanol. This is methanol. Cyclohex, 1 ene, this is that first one, 1 ene, 1 methanol, methanol, OL, methanol. Now here this is a cyclohexane, not phenol. This is cyclohexene. Okay, cyclohex 2 ene, 1 all. See, this is 2, second carbon, first priority whom you have to give OH. So cyclohex 1 ene, 1 all. Hope you're clear with that, right? Now what we are going to say, it's a benzylic alcohol. Before we have seen allylic alcohol, that is simple OH group attaches with the saturated carbon that is connected with the double bond. So that is called allylic alcohol. This is aliphatic. Now what we are going to say, it is a aromatic. So OH group connected with the saturated carbon that is attached with aromatic. So that is called benzylic alcohol. Benzylic alcohol. So benzylic alcohol also we can say one more name, phenyl, methanol, OL. Okay, now this one, that same aromatic ring, benzene ring connected with one carbon here, one carbon is here, bond line structure. So 2, so phenyl ethanol. Okay, the next one, 2 phenyl, see here 2 phenyl, 2 propane all, 2 propane all. Okay, see 2 propane, 1, 2, 3, this carbon which is attached with this OH as well as this carbon which is attached with phenyl. Okay, so 2 phenyl, 2 propane OL. Okay, hope you're clear with it. So we have seen in this allylic alcohol, benzylic alcohol, primary, secondary, tertiary in sp3 hybridization based on what it is? OH group connected with that carbon. Now, sp2 hybridized. Now, what we have seen, it is sp3. Now, what we are going to see, it is sp2. That is very simple and easiest. Now the last one, it is compound containing OH group based on sp2 hybridization. Now here, in this point, 2 points are here, vinylic and phenols. So vinylic, it is OH group connected with what it is? Unsaturated carbon. So that is called vinylic alcohol. Phenols means OH group directly attaches to the benzene ring. So that is what it is, phenols. Okay, now here, what is the name? Ethane, CH2 double bond CH2. In that one hydrogen is replaced by OH. So ethene, enol, enol. And the same way here, propene, prop 1 en, 1 ol. Prop 1 en, 1 ol. Okay, now this is not benzene, this is a cyclohexene. Okay, so cyclohexene, cyclohex 1 in 1 all. Cyclohex e 1 in 1 all. Cyclohex 1 in 1 all. The same way, this is so easily you can identify. Now, benzylic, that means phenols, aromatic ring, OH group directly attaches to that benzene. What benzene ring? Yeah, this is called phenol. Phenol, the great phenol we are going to see. That's very important topic what we are going to learn from this chapter. Okay, now this is a priority. What it is? OH group, it is functional group, which is we have to give first priority. So 1, 2, 3. So 3-methyl phenol. Then this is, by the time you yourself will say 3 and 5. 1, 2, 3, 4, 5. So here 3 and 5. What it is? Phenol. 3 and 5. Dimethyl phenol. Hope you're clear with this. Okay, so what are the points we have gone through? These are all asked from the conceptual based questions, or choose the correct answer, objective type questions. You can expect such kind of question. Okay, so here 2 points we have gone through. Classification based on what it is, OH, number of OH groups. Classification based on hybridization, sp2, sp3. So in that monohydric, dihydric, polyhydric we have seen. And the same way, next sp2, sp3. So in sp3, what are the points we have gone through? In that sp3, primary, secondary, tertiary, and allylic and benzylic. And here, sp2 hybridization, here vinylic and phenols. Hope you're clear. Vinylic and phenol, here directly OH group attaches to the double bond. That is aliphatic and here aromatic ring. In that, what it is, sp3 hybridization, OH group attaches with the saturated carbon, that is attaches with that double bond, allylic and benzylic. Hope you're clear with it. All these points, whatever we have gone through. Thanks for watching.